Let's get back to our specific product. How are we going to get a feel for these things? Or put this thing together effectively? There is one involved here. Exist. In our small team. Or in our design ability. In this level, where the development ability is not very strong, we are usually ignored, are often ignored, the most overlooked. A very crucial thing. Remember, I've advised many companies. I also talk to the industry. Technicians in companies large and small have communicated. We can make some better products. I had a lot of great ideas. We've got some pretty good ideas, even some products already on the market. Large-scale application. But once something goes wrong, we discover that we start at the source. We just missed this one. And missed this benchmark. What is the final impact? It's a special trouble for me to find problems. And no clue. No clue why. We just talked about. Our products are going to be matched with PC boards. Do you want to install our products? Our products are not matched by male and female. Look at a certain part independently. There seems to be no problem with a certain product. But put all the products. Put our installation. Pack our cooperation together. We found a lot of problems because there's a lot going on. It comes in combination. It's a combination of flatness. What we just talked about. Flatness is easy to achieve because it's just one surface of an injection molded part. Right, so this flatness is easy to achieve. I just need to control my bets. Injection molding. The system is okay. What about complementarity? It could be my 3 parts. Or N features of N parts. The supply chain that needs to be formed, so it covers both your part manufacturing process. It also covers your so-called assembly, manufacturing process, even your design. So in the process, this is very difficult to achieve with the application of complementarity to our products. Very important. A very simple truth. My connector has a flange on it. There are 4 holes in the flange. The processing of my 4 holes. It's very easy to implement for my parts. This is too simple to say, but I need to install these 4 holes into. It needs to be installed into my system. For the system, if it is in my installation system, the accuracy requirements of the 4 holes are very high. Then ask this time. This processing capacity is not easy to achieve. It increases the difficulty. Then if I am in the process, I need to add another gasket, the same sealing gasket. It also needs 4 holes. Then if I make this one and this 2, and my mounting system, this 3 4 holes, this is a system of 4 holes. How to effectively connect together? Then it gets complicated. It's easy when doing 2 alone. 2 with 3 is not difficult. But if I were to put 1 and 2 together, 3 all together, that's how you go about doing this design benchmark. Which installation benchmark do you use? Which one is the most convenient for you? It best expresses our whole cooperation. To be your design benchmark, your manufacturing benchmark, even your installation and application benchmarks. It's just a cushion. It's just a cushion. What about those we just talked about? There is N holes. Ah, there are terminals in the hole. Then when we mate with our male and female, let's say I have 48 holes here. It's easy for me to match one hole to another. It is not easy for me to match 48 holes with 48 holes. That assumes that in addition to my 48 holes, I still have some so-called grounding. Grounding plate? There are also some so-called card hooks. Suppose there is also a so-called secondary lock. There is such a structure. Then ask these characteristics 1 to 48 plus these things. Add this ABC. How can we achieve its effective cooperation? There is no problem for you to make this product alone. But if you consider the installation cooperation of the two products, there will be problems. You have to consider the relative position of each other. So there is one more we call, or call. Ah, these two are the same. That for positivity and positivity in the entire connector system, including our design and manufacturing, and during the application process. How does it work? You have to think about the technology. You have to think about that. Then there would be a problem. That's what a lot of people are asking me. Then how should we choose the benchmark?